Good morning, everyone. Today I am going to start a workshop on computer or digital forensic. Okay. So, myself, Sanchan Bhaumik, working as a senior information security analyst in ISOEH, Indian School of Ethical Hacking, and my expertise is in ethical hacking, penetration testing, and digital computer forensic investigation. Right. So today I am going to discuss about digital forensic. So though it is not enough to discuss all about the digital forensic, but I want to give you a small idea, a basic idea, and the essence of the digital forensic. How a forensic investigator investigate a particular system or the memory. So I'm going to discuss all that thing in briefly, and I want to give you a essence about the digital forensic. Right. So basically, I'm going to discuss about the introduction part, and then what is digital crime and what is computer or digital forensic, and the procedure of computer forensic, and how to collect the evidence and how to examine or analysis the evidence, and largely we need to report this, right? And in practical content, uh, I can show you some digital forensic tools like maybe Ftk Imager or maybe dump it like this, and also the examination tool like volatility or maybe autopsy or maybe any Hex Editor, all that. Now, so before going to start the digital forensic investigation, so first I would like to discuss about the digital crime, right? So what is a digital crime? So any crime where any digital device is connected. That means digital device means the device like computer or maybe pen drive, hard disk, mobile, even if the CCTV camera or anything digital, even Fitbit also, okay, drone, anything. So any crime where the computer or any digital device is a tool, target, or both. That means a digital evidence is used as a tool for that particular crime, or maybe as a target for that particular crime. So that is we known as a digital crime. Basically, where a digital evidence is involved. Okay. Crime against computer or digital data or system, and crime against CIA, that is the confidentiality, integrity, and availability, right? Unauthorized access, that is also may sometimes happen into the system, like someone hacked the system, okay, someone penetrate inside the system and delete some data or maybe steal some data, right? So all that are the unauthorized access and modification of the data or computer or mobile or digital system, that is also a digital crime. That means any digital evidence that is related or involved to that particular crime, that is we known as the digital crime. I can give you some example like digital crime in any web application. That means suppose someone had some website, okay, and maybe steal some data or uh, maybe give some impact over the business, okay, so that is also a digital crime. Or maybe sometimes we can see some computer is hacked by a hacker and stealing the data, or maybe change something, or maybe send something, or maybe or maybe sometimes some DOS or DDoS attack also happened into the into a application to down that particular application and give some monetary loss or bank fraud, right? Means bank fraud in digital means uh, steal the uh, amount from the bank account by maybe using some social engineering attack or maybe some other kind of attack, ransomware attack. Okay, so all that are the example of digital crime. So to deal with all these type of digital crime and to find out what actually happened and how happened and who is the criminal, so to find out all that things we need to analysis all that crime. So that is known as the digital forensic investigation. So what is a computer or digital forensic? An application of scientific method to computer investigation and analysis in order to gather evidence suitable for presentation in a court of law or a legal body. It's basically perform a structured investigation while maintaining a documented chain of evidence to find out exactly what happened on a computer and who was responsible for it. Right. So the computer forensic has become its own area of scientific expertise with accompanying the coursework and certification. And computer forensic is somehow different, like means somehow it's a subset of a digital forensic. In digital forensic, we include any digital evidence that include maybe also, as I told you, CCTV camera, maybe Fitbit, maybe drone, maybe any mobile phone, any digital evidence, right? But the computer forensic is a subset of digital forensic which only deals with a computer, desktop or laptop or something like this, right? So in broader sense, we need to use the digital forensic and the computer forensic is restricted our domain on only into the computer or maybe desktop or laptop, right? Now, there are few steps are there, that is computer forensic procedures which maybe we follow at the time of the investigation, right? So mainly these phases are there, these four phases are there, like acquisition, examination, analysis and presentation, right? So these are the forensic processes, digital forensic investigation process. So at first stage we need to acquisition and preservation. That means we need to collect the data from the crime scene, right? That means suppose some crime has been happened. So after immediately reporting that particular crime, right, as a first responder team, which basically respond at first after immediately happening the uh, crime or incident, right? So as a first responder team, we need to respond and we need to go to the crime scene and first we need to identify is there any crime is happened or not, and if any crime is happened, so we need to investigate the crime scene thoroughly, like normal investigation, right? And we need to collect each and every digital evidence from the crime scene, like maybe computer, maybe laptop, maybe hard disk, maybe pen drive, or maybe other evidence also. I mean, any other digital evidence also. And you also need to do maintain and need to follow some procedure at the time of doing the same. What is that mean? Suppose you got a computer, right? And the computer is turned on. So what you need to do as a computer forensic or digital forensic investigator? Should I shut down the computer and bring the computer to the forensic lab, or maybe we can collect the evidence from the turned on computer. So what we need to do, so that is also recommended in different situation, means according to the situation, according to the crime, we need to do follow some procedure. Means suppose I am giving you some examples. Suppose I at the crime scene, as a forensic investigator, I get that some computer is turned on. So at that time, and some attack or maybe some crime is performed to that particular computer. So at that sense, maybe our first task is to collect the volatile memory evidence, right? Memory are basically two types. One is the volatile memory and another one is the non-volatile memory. So in volatile memory, it's basically a fragile memory. That means once the computer is turned off, so all the data are gone from the volatile memory. So RAM is a example of volatile memory, right? Then a non-volatile memory, that means the memory which is basically non-fragile, that means permanently stored, that is the hard disk is the example of non-volatile memory, right? So suppose once we got a computer is turned on, so our first aim is to collect the evidence from the non-volatile memory and then go for the volatile first we need to collect the evidence from the volatile memory, that is from RAM, and then go for the non-volatile memory. So depending upon the order of volatility, first we need to collect the evidence or getting the evidence from the most fragile or most volatile memory, and then come to the less volatile part. So suppose there is a computer with a hard disk, then if it is turned on, then our first aim is to collect the evidence, that is called something imaging or data acquisition. Later I will tell that what is data acquisition and how to do that. So we need to set a order of volatility, and in order of volatility, the most volatile data is the RAM. So first we need to collect the data or evidence from RAM memory, and after that we need to collect the evidence from the hard disk, and then we need to send the data to the examination lab, right? Or sometimes we can see some attack like DOS attack or DDoS attack maybe happen. So in that case, maybe sometimes we need to, or maybe some network or some kind of attack is happening into the system. So in that case, maybe sometimes we need to disconnect the system from the internet or network, right? And then after collecting the evidence, we need to shut down the system. So the first phase of the computer or digital forensic investigation is acquisition of the data and preservation. And one more thing that is very important, whenever we are going to analyze a particular hard disk or pen drive or any memory, right? Never we investigate it upon the actual evidence. Means suppose we are going to analyze a USB drive, right? But never will analyze that actual evidence, that actual USB drive. So what we need to do? We need to create a exact copy of that particular evidence. Okay. Here the copy doesn't mean the normal copy paste, right? Here the copy means the exact copy, that means bit by bit data copy, right? So for that we need to use some software, like maybe for volatile memory we use Dumpit or Ftk Imager, or maybe non-volatile memory we use Ftk Imager, DP2C. So lots of tools are there which basically create a bit by bit copy, that is actually called a forensic imaging, right? So in data acquisition part, first we need to set the order of volatility of the evidence, and first we need to perform the forensic imaging of the most volatile memory and then go to the less volatile memory. So that is the data acquisition part, and also we need to check the both the data, that means the actual evidence and and the image is the exact copy. So how we can do that? So to check that particular things, we need to uh, we need to check the data integrity, right? So how can we check the data integrity? By checking the hash value, right? Maybe we can use a different algorithm to check the hash value, like we can use we can use MD5, or maybe SHA 1 or SHA 128, or maybe SHA 256. It's basically a hash value, so which is basically used to check the data integrity. If the hash value of both the evidence and the image are same, then both the copy are exact copy, because whenever we analysis further, we will analysis upon the forensic image. That means we will analyze the exact copy, and the result and the mm, analysis report is submitted to the court of law, that is performed upon the copy of the evidence, right? So in that case, you need to prove that both the things, the evidence and the exact copy, are similar, right? So for that particular things, you need to check the hash value, otherwise the court of law will not accept your analysis report, right? So in first phase, in data acquisition phase, we need to create the exact copy of the evidence by using the forensic imaging tool, and we also need to check the data integrity, that is we need to calculate the hash value, and we need to check is that match or not. If it is match, then our imaging is complete and it's correct, and if it is not, then the imaging is not correct, so we need to image it again, right? Okay. So the next phase is the examination. Okay, as I told you, okay, we need to go to the means we need to send the uh, data, means the accused data, to the lab for examination, and for that we need to follow a chain of custody, right? What is the chain of custody? So a chain of custody is basically specify how the data is how the data custody has been changed to send the evidence from the forensic uh, means from the crime scene to the forensic lab, right? So we need to send that particular data or evidence to the forensic lab, and we also need to set up a lab with forensic lab for analysis, okay, with a perfect hardware and software tools. So for that we use some recommended machines and software, right? So like we can use the Fred machine, or maybe some other forensic investigation machine which have very good configuration, right? Because time is very important, right, for forensic investigation. If we delay the analysis, then we may lost the crime and criminal as well. So that's why we need a very good software, and also the recommended computer forensic software like maybe FTK, maybe parabens different forensic investigation tools are there, NCase, okay, forensic, so lots of tools are there. So once we create the examination lab, then we need to go to analysis the case. So uh, by using the forensic workstation and the that is the hardware and software both include in the forensic examination machine. Okay, so using that we need to analyze the evidence, and we need to collect the evidence, and we need to find out the suspect and crime and criminal as well, and finally we need to create the report and we need to represent this in the court of law. So this is the computer forensic procedure. So later I will definitely show you all these procedures practically one by one. Okay. So here is the few steps which is used for investigation, step-by-step procedure for forensic investigation. So first we need to identify the computer crime and then collect the preliminary evidence, and after that we need to obtain the court warrant for seizure. Of course, without court warrant we cannot seize any evidence. Then perform the first responder procedure as I told you and seize the evidence at the crime scene, and then transport the evidence in the forensic laboratory with maintaining the proper chain of custody, and then create 2-bit strip copies of the evidence and generate the MD5 or SHA1 or SHA256 checksum on that particular image to check the data integrity. Right. Maintain a chain of custody, store the original evidence in a secure location, okay, and analyze the image copy for evidence and prepare a forensic report finally, and submit that report to the client or maybe to the court of law, and if required you need to attend the court and testify as an expert witness. So these are the step-by-step procedure for forensic investigation. Okay. Okay. Now let's come to the practical part. Okay. So first we'll start from the data acquisition, right? So for data acquisition, we need to create the copy of both the type of memory. That is, one is the volatile memory and another one is the non-volatile memory. So first start with the volatile memory, that is RAM. So for to create the image of RAM, that is the volatile memory, we can use the tool dump it. Okay. So it's a open source tool, right? It's a open source tool and very simple to use. Just you need to click on the file and it will start taking the image of the volatile memory, that is RAM. Okay. So where is the tool dump it? And once we click on the tool dump it will ask for the permission. Do you want to allow this app to make changes to your device? Yes. Once we click yes, it will open into the CMD and with a prompt that are you sure want to continue? If we press Y, then it will start taking the image of the volatile memory, that is RAM. Okay, so press Y. So now it's taking the image of the volatile memory, it is RAM. So it will take some time depending upon the RAM size. It will take some time to take the image of the RAM memory. So once we complete this task, that means once we are able to take the images of the volatile memory, that is RAM, then further we'll perform the data acquisition of the non-volatile memory, that is the hard disk or pen drive or these things, and then we'll analyze that. Okay, so processing success. So successfully we are able to take the images of the RAM, right? See, you can check. See, you can got the RAM image here. Okay, and it's a raw format. So you can check that raw format. Okay. So now we can also do that by using the tool Ftk Imager as well. So now I am going to show you how to use the tool Ftk Imager to take the image of volatile and non-volatile memory both. So here is my tool Ftk Imager. So you need to install this. this is my tool access data Ftk Imager. So Ftk Imager is free, but the full toolkit is not free, so it's a paid tool. So now I'm going to use the tool access data Ftk Imager to create the image of the volatile and non-volatile memory both. So first start from the volatile memory, that is RAM. So go to file and there is the option capture memory. So click on the capture memory option and it will start taking the image of your RAM. So you need to select the destination path. Okay, so maybe it's in desktop, so selecting the desktop. So this is the destination path, and you can also include the page file, and you can also create the AD1 file, that is the access data format, and then you click on the capture memory option to start imaging. Okay, memory capture finished successfully. So this way we can capture the RAM memory, right? Now next go for the non-volatile memory, that is maybe hard disks or whatever, means pen drive or external hard disks, main hard disks, whatever. So for that you need to go to the option file and then create disk image option. Now there are few options are available like physical drive, logical drive, image file, and content of a folder, and for CD DVD you can also use Amigo device, right? So now suppose you want to create an image of a physical drive, means whole physical drive. So for that you need to use the option physical drive. Now suppose you want to create an image of a logical drive, that means suppose like for C drive, system drive, or maybe D drive, or maybe other logical drive. So for that you need to use the option logical drive. Then image file. So if you want to create a forensic imaging of an image file, then go for the image file option, or maybe content of a folder. If you want to create an image of a folder, then you can go for the content of a folder option, and for CD DVD you can go for the last option. Now suppose I am going to create a logical drive image. Okay, go to next, and now see it will show all the logical drive. See how many logical drives are there? There are two logical drives are there, C and E. So it will show both the logical drives C and E. Okay, so according to that you need to choose one. And suppose I choose the option drive C. Then you also need to add the destination, right? So you also need to choose the format. So suppose I am choosing the raw format, that is the DD. You can also choose other format like E01 format or advanced forensic format, AFF, whatever, but I prefer the raw format. Different tools use their different format maybe. Okay, and go next. Then you need to choose some details regarding the case. So you need to put the case number. Then you also need to choose the evidence number, then unique description. Okay, examiner name you also need to put, and then notes. Then image destination folder, you also need to provide the image destination folder. Then image file name. Then there is an option of image fragment size. Okay. So here it's showing 1500 MB. So what is the image fragment size? That means image fragment size is basically fragment the image into different parts. I mean, suppose I am giving you one example. Suppose you have a 10 GB of memory space in a particular drive. Okay. So once we use the image fragment size of 1500 MB, then it will collect, means it will basically create a fragmentation size of maximum 1500 MB. So to store all these 10 GB data, it will may use how many fragmentation? That is 10,000. Actually, if we go for the computer science logic, then go for 1024 MB, and for market size you can go for 1000 MB for 1 GB. Okay, so if I go for the market size, then 10,000 divided by 1500 MB, so we need that much fragment, right? So it's almost 7 different file is created for that particular image, and we just use the first one, and the remaining fragment are basically linked up with the previous one. It will take automatic. So why you use that? Maybe there is not enough space to store the whole image together, right? So in that case, if we use the fragmentation, then we can store the image into multiple hard disks as well, right? So for that we use this fragment size, right? So maybe I can do the fragment size like this, okay, or maybe like 5000 MB. And compression, you can also compress the image. If you use 0, then no compression. If you use 1, then the fastest compression, and if you use 9, is the smallest compression. So according to the order, it will take that. And you can also use the encryption, but this time I am not using that encryption. Okay, then go for the finish. And one more thing very important, that is image file name. Here we need to give the image file name excluding the extension, because previously we already set the extension. Here I set the extension as raw, that is pd. Okay, then go for finish. And here you need to check this box, verify the image after they are created. This is the integrity check. That means the image which has been created, that is the exact copy of the actual evidence, yes or no. So for that we need to verify the image after they are created by calculating the hash value, right? Then start. It will start creating image. So it will take some time, right, to create the image. So depending upon the space, it will take the time. Okay, so it will basically take some time because my C drive is not so small. It's around 214 GB, so it will take some time. So I hope everyone can understand the procedure how one can take the image for volatile and non-volatile both the memory, right? So let it be continuing in the background. So now I'll start the analysis part, right? So our data acquisition part is now over. So now I'm going to the next phase, that is the analysis part, right? So once we create the forensic examination machine, okay, analysis machine, and also collect the evidence, then our next task is to analyze that. So here for analysis, first start from the volatile memory analysis, that is RAM analysis, right? So for RAM analysis we need two tools. One is a Hex Editor. So any Hex Editor we can use for RAM analysis. Okay, so let's use a Hex Editor. Any Hex Editor you can use. I am using HXT. You can use any other Hex Editor. It basically check the content of the memory and convert it into the corresponding hex value, and also show the corresponding string actually. Okay. HXT is already downloaded. So let's open the tool HXT and make it into background. Okay. So here is my tool HXT. So now I'm going to use the tool HXT to analyze the RAM memory. Okay. So now for the simplicity, I'm not going to open the RAM memory which I have been taking from this system, because lots of sensitive information are there inside this RAM memory, right? What kind of information we can get from a RAM memory? We can get the information like which processes is running into the volatile memory, or maybe sometimes any chat or any email sent, okay, and maybe username or password of your account, maybe email account or maybe other account which has been opened recently from this system. So you can also get all that information. So this is very sensitive. So that's why I'm not going to analyze the uh, RAM dump which is taken from my system. So I am rather using uh, another RAM memory which has been taken previously. Okay, that is, the name is test image file. So this is also images taken from a RAM memory. Okay, so I am going to analyze this RAM memory, right? So because there are lots of sensitive information are there inside the RAM. So now, so how can we analyze this volatile memory or RAM memory? So first we will analyze the RAM memory by using the any hex editor, right, to check the content of the memory space, and if there is any meaningful string are present inside the RAM or not. So for that we need to use the tool hex editor, right? So let's open the hex editor. Here is my tool hex editor, and open the RAM image to check the content of the RAM image. So go to the option file and then go to the option open, and then go to the folder desktop where I basically store the evidence. So test image, right? Open this, and now see, we got the content of the RAM image. So this is the offset value, that is the address of the memory space, and this is the content in hex format, and here is the decoded text. So all these are showing 000000, and decoded text is nothing. That means the memory space, that particular memory space is blank, nothing was actually there. So that's why it's showing 0000, and decoded text is nothing. So let's check all the memory space thoroughly, right? So scroll down. So you can see the offset value has been changed, but still it's showing the memory's content of the memory space is 0000, and decoded text is nothing. That means still it's blank. Okay, so let's continue scrolling to check all the memory space of this RAM image. So continue. So actually it will take lots of time to check all the content of the memory space thoroughly, because it's not a very small in nature. So it will take uh, lots of time to analyze a RAM memory thoroughly, right? Content of a RAM memory thoroughly. So let's go like this. So I'm scrolling down fast and see, is there anything stored inside the RAM or not? Yeah, I got something. Okay, but the thing is that all the decoded text is not in the readable format. That means, so all the content of the RAM memory is basically converted into the string, but maybe some information like some instruction or some other thing is, if we convert this into the corresponding text, then we cannot get any meaningful string. So let's analyze for any meaningful string which has been may be stored inside the RAM image. Maybe some email ID, maybe some password, maybe some content, or maybe some chat. Okay, all that things. So for that, we need to check this content of the RAM thoroughly. So this is the first steps of RAM analysis, but this is not the all thing. So this is only to find out if there is any meaningful string is there inside the RAM image. So for that, we'll analyze these things. Okay. Let's go. Let's scrolling. So something is there. NTLDR is corrupt. Okay, computer or run a configuration file. Windows NT has not found enough extended memory. 7 MB of extended memory is required to run Windows NT. You may need to upgrade your computer or run a configuration program provided by the manufacturer memory. Okay. Anything else? Maybe. So this way we can get the meaningful string if anything is stored inside this particular uh, RAM image. Right. So this is the first steps of analysis of a volatile memory. Now what next? Other than this meaningful string like email ID or maybe username or maybe password or maybe chat, we can also get some other information, right? Like what kind of information? Like the processes which are running, okay. And even if sometime we can also get the content of a file which has been recently opened, and if it is maybe encrypted or password protected inside the hard disk, but whenever the user open this, so it will open in the plain text format into the RAM memory, then only the user can see that. So by capturing the RAM image, we can also get that encrypted file which has been recently opened by the user also, even the network connection, registry information. So lots of information we can get from the RAM image. But how can you get that? So for that, we need to analyze the RAM image, and this is the first steps by using any hex editor to check the content of the RAM image for any meaningful string. And then in the next steps, we need to use the tool volatility to further analyze and collect the information about the uh, processes, connections, CMD commands, so for registry information. Okay, for all that things. Now I am going to show you the tool volatility to get all that detailed information from a RAM image, right? So let's start. So here is my tool volatility. So how to run this tool volatility? So though it is a exe file format, okay, so we can check that it's a exe file format. See, application file, but we cannot open this like other exe file just by double clicking it. So we need to open this file from the CMD. Okay, so let's open CMD and go to this particular location. Okay. let's go to the location. So this is the location. See users unknown, then go to desktop. And then go inside the volatility folder. Inside this again volatility, okay, now we are inside the directory, right? Now I am going to analyze the RAM image, this particular RAM image, okay, which I previously analyzed by using the Hex Editor. Okay, so I'm just copy this RAM image and paste it inside the inside the directory where the volatility is. So because it is very easy to examine the RAM image from the same directory where the volatility is, otherwise always we need to put the path and all that details. Okay, so that's why I'm just putting the RAM image inside the same folder where the volatility tool is. Okay, so now how can you run this tool volatility? So for that, go to the CMD and go to that particular location, or else simply by doing this you can also go to that particular directory directly. Okay, see, and now from this directory first you need to call the tool volatility, right? So this is the tool name. Okay, and then you need to provide the file which you want to analyze. Dash F specify the file name. So I'm going to analyze the test image dot raw file. Okay, and the first command which you need to give to find out the information about the image, that is the image info module. Okay, image info module, right? So what is image info? So for high level summary of the memory sample I am going to analyze, okay, we need to use this command image info. So this command is used to identify the operating system and service pack and the hardware architecture, that is 32-bit or 64-bit, okay, for that particular system from where the RAM image has been taken, right? So for that we need to use this module or command image info. So this is the first command which you need to follow. Otherwise, if you have the information about the system from where we have taken the RAM image, so in that case no need to use this command. Directly we use the details information which we collect at the time of evidence or data acquisition, right? We use that particular information for further analysis, but here we don't have the actual information about the uh, images, so that's why at first we need to use the command image info, right? So let's go. Actually, it will take some time to analyze the uh, evidence, right? RAM image. So that's why we actually need so powerful machine for analysis, right? So you got the result. So suggested profile is showing Windows XP Service Pack 2 and 32-bit, right? So next start with this one. So further we can also use the Kdbg Scan command. Okay. So in image info, we basically simply it's provide the profile suggestion. So where the Kdbg Scan is designed to positively identify the correct profile and the correct Kdbg address, right? So if there, so this plugin basically scans the Kdbg header signature linked to the volatility profile and applies the sanity check to reduce the false positive, right? So further to check the profile more precisely, and we use the command Kdbg Scan, right? So how can you use that? So this is the suggested profile, so we need to use then the same volatility, then dash f, provide the file name, right? Then the file is test image, and you also need to provide the profile which we got in the previous command. So can you give that dash dash profile dash dash profile, that is equals to Windows XP Service Pack 2 32-bit, and then use the command Kdbg Scan. Okay. So again, I already told you it will take some time to scan. So let's wait for the result. So it's showing suggested profile is Windows XP Service Pack 2 32-bit. Okay, so let's use this profile for further. So next, suppose we want to use the module PS list. So to list the processes of a system, we use the command PS list. It basically find out the active processes which are running at the system at the time when we uh, took the images from the RAM. Okay, so the command is similar. So it's volatility, then dash F, provide the file name, then test image, then dash dash profile. Need to use this profile as well. So profile equals to this, and then the command we'll use, that is ps list. Okay, this is the command to find out all the active processes which are running at that particular time when we will take the RAM image, right? Okay, see, we got all the process list which are running into that particular system. So for system process with the PID 4, PPID is 0, that is the parent process ID, and here is the start time and exit time. Then SMSS.exe with the process ID 376 and parent process ID 4, that is it's a sub child process or sub process of the system process. Then CRSS.exe, that is with PID 528 and PPID 376, that means it's a child process of the parent process SMSS.exe, right? So this way it will list down all the active process which are running at that time into that particular system, right? Now we can also use the command ps3 to find out the list in hierarchical structure, by which we can easily find out the structure, means which is the parent process and which are the child process for a particular process running into the system, right? So the command is very similar, just the change is in module. Okay, so here now we will use the module ps3. So volatility dash f, specify the file name. Okay, so test image, then dash dash profile. Always we need to provide the profile, otherwise we cannot get the result. Okay, and then the command or module is ps3. Okay, see, it will show all the active processes in a hierarchical structure. So system is the process with PID 4, and there are a sub process, a child process of system, that is SMSS.exe, and SMSS.exe have two child process, that is CRSS.exe and WinLogon.exe, and this is also have one sub process, services.exe, and it also have 1, 2, 3, 4, 5 sub process. Okay, so this way we can get all the process list in a hierarchical structure, right? Now next command or module we want to execute, that is ps scan, right? So to enumerate the process using the pool tag scanning, okay, we'll use the command ps scan, and this can find the processes that previously terminated or inactive. So the by the command pscan we can get the hidden process or previously terminated process. It may be unlinked or hidden by a rootkit. So we can also get that particular process as well. So what would be the command? So the command is volatility, then dash f, quite similar, specify the file name, then you need to provide the profile, that is equals to Windows XP Surface Pack 2 32-bit, and the command we need to use, that is ps scan. Okay. So here I think there is no hidden or previously terminated process was there. So that's why we cannot get any such process. Okay. So otherwise, if there is any previously terminated process or hidden process are there, then we can also get that by using the command scan. Okay. Now suppose we want to list down all the DLL file, right? For all the processes or maybe for a particular process. So for that we'll use the command DLL list to display a process DLL file. So the command is quite similar, volatility dash if then the file name, then profile, then the command is DLL list. Okay, let's see. We've got all the DLL list for all the processes which are running into the target machine. Okay, so now suppose we want to check the DLL file for only a particular process. Here we get the list of all the processes and the corresponding DLL file. Now suppose we want to find out the DLL file related to a particular process, right? So for that we need to specify the process ID by -b option followed by the process ID. Suppose we want to check the DLL file for the process dumpit.exe which is running into the system with the process ID 1028. Now see, we only got the list of DLL file which has been used by that particular process, right? So this way we can also get the DLL file, all the DLL file. Even not only get the DLL file, we can also we can also dump the DLL file as well for further analysis as well. So how can we dump the DLL file? By using the command DLL dump. DLL dump. But along with this, you also need to specify the destination folder. So suppose -D is used for the destination folder, and I am choosing the destination folder as not this one. Suppose volatility, creating a file, creating a folder DLL dump. So this is the path where you want to store the DLL file. Okay. So let's open and the command DLL dump we already use, and -d, then this is the location where we want to store all the DLL file, means we want to dump all the DLL file. So it will basically dumping all the processes in DLL file of all the processes which are running. So it will take lots of time to dump all the DLL file for all the processes running into the system. So let's terminate this task. Okay, and now I'm just going to dump all the DLL file for a particular process only. Okay, so let's do. The command is same. Then you need to provide means specify the process ID. So suppose I'm going to dump all the DLL file for the process ID 1028, that is dumpit.exe. See, got all the DLL file. We dump all the DLL file related to the process ID 1028. So similarly, not only the DLL file, we can also dump the process as well, right? Suppose we think about some process is suspicious, or maybe we need to check that process further, what it's actually doing into the system. So for that, for further analysis, we need to dump that particular process, right? So how can you do that? The same thing. Now we need to use the command proc dump rather than DLL dump for dumping the DLL file. proc dump, and rest are similar. You need to provide the location and the process ID as well. Okay, so check this one. I'm just deleting all the dump DLL file and store the process into that particular directory. Okay. Okay, so it's already dumped, and let's check. See, here is the dump of the process which are running into the machine from where we take the RAM image. So further, we need to analyze this particular process and using the malware analysis or something like this, because sometimes we can see some malware is running into the system, and using that particular malware, maybe some hacker connect with that particular system, basically enter or penetrate inside that particular system. So to know what actually a particular process is doing into the system, for that we need to analyze that, right? So after getting the dump of that particular process, we need to analyze that for all the details what it actually performing into the system, right? So this way, not only this, lots of command are there by which we can get lots of information from the RAM image, but this is not possible to discuss all the command which we will use for to analyze the RAM, but I am just trying to show you few important command which is within this stipulated time period, right? So I would like to show you few 2 or 3 more command by important command by which you can get lots of information. Like one of the important command is like connections, right? By which we can get all the connection which is established with that particular system, right? So let's go for the command, that is volatility -f is the file name. Okay, and then uh, test image, then test profile equals to, sorry, profile equals to this, and the command is connection. So it will give us the details of all the connection, means if there is any connection is established into the system, it will provide us that information about the connection, right? So we got the table, but it's blank. That means there is no such connection is there. So that's why it's blank. Otherwise, if there is any connection is established with the system, then we will get that with the local IP and remote IP and the PID which is responsible for that particular connection, right? So further, we can also use the command scan, right, to get any previously terminated connection. If there is any connection previously terminated, we can also get that. So uh, okay, let's see. No, it's blank. That means there is no previously terminated connection is also there. So similarly, we can also get the details of command prompt. Means if any command is executed from the command prompt, we can also get that by using the command cmd scan. Okay, so same. The command is cmd scan. Okay. So yeah, we execute the command dumpit.exe, so that will be there. But if we want to get the input as well as the output screen in command prompt, so for that you need to use the command consoles. See, so this is the input and output window of the CMD. So this way we can get lots of information from the RAM image. So this is not possible to show you all the command and all the types of information which we can gather. Okay, so like this privs is the command by which we can get the process privileges, right? Envars is also another command by which we can get or we can display the process environment variables, var info. Okay, then memory map and registry information. So lots of information we can get, event log. Okay, explorer history, so we can internet explorer history, so we can get lots of information by using the tool volatility, right? So but this is not possible to show all that command in this stipulated time. So this is few of the important command which I have been shown you so in this session. So this way we can analyze the RAM image by using the tool volatility, right? So now I don't have much more time, so let's quickly see how we can analyze the non-volatile memory, that is the hard disk, right? So for hard disk there are lots of tools are there, like autopsy is there, FTK is there, NCase, okay. Then lots of tools from Paraven. So lots of tools are there, but mainly here I will show you the tool autopsy. As autopsy is an open source tool and other tools are paid tool and very costly tool which have been used for professional purpose, right? So for that we need the images taken from the non-volatile memory. So here I have an image of a laptop and a memory card related to a particular case, right? This too. So quickly I'm giving a scenario. So basically a dog is kidnapped. So that means a dog nap is happened, and from the investigation we can spot that particular dog in a shopping mall, and whenever police try to catch them, they escape from there, and they got two evidence from the parking lot. One is the laptop and another one is the memory card inserted inside the laptop, right? Memory card from a mobile maybe, and that is inserted inside the laptop. So we got these two evidence, right? So now let's analyze this to non-volatile memory, that is the hard disk, by using the tool, one of the very good and open source tool, that is Autopsy. So let's open the tool Autopsy. So I hope you already see how we can create the image. So I am cancelling this process. Okay. Okay. So for the first time, we need to create the case. So go to the option new case. Otherwise, you can also go into the new case from here as well. So now from here I am going to the option new case, and then first you need to provide the case information. So case name, right? So suppose giving the name .name at the basic directory. Suppose I am creating a directory into the desktop. Okay, the name .name, and use that directory as a base directory. Okay. Then case type single user or multi-user. You can also use the multi-user if a multiple person can access, want to access this particular case. But this time I'm go for the single user. Okay. Then go. This is the optional information. Okay. Then finish. It's creating the cache database. Okay. So now select the type of data source. So I am basically going to insert the disk image, right? So if you want to add the local disk or maybe logical file, then you can choose accordingly. So here I am just going to select the source data source as a disk image. Okay. So use this option, then go next, and this is the path. Here the evidence file. So first go for the laptop, then next, then this is the option which you want to find out. Okay, so if we particularly try to find out some particular information, then go for that particular option only, but this time I'm going for all the information from that particular image. Okay, go for next. Then it will configure the ingest module, right? So it will take some time to configure the case. Okay, finish. Now it will take some time to analyze the image, and then it will actually take some time to analyze the data, means analyze the evidence. So meanwhile, I'm just showing you all the result area. Okay, means all the analytically there are four main part. One is the data source, then views, then result, and then tag. Okay, so in the data source area, we can get all the data by their volume, means that by their uh, partition. Okay, so volume unallocated, then volume 4 data partition. Okay, and all these are the file, so we can get all the details from here. Okay, then volume 5, that is EFI system partition, volume 6, volume 7, volume 8 is also unallocated. So here we can get the total file structure according to the evidence, right? So you can get all the details by going to that particular location, right? So this is the data source. So here we can get all the evidence by their data source. Then views, here we can get the file by their extension, it is image, maybe all the document are there like HTML, Office. Here we basically get all the files by their extension, right? So if we suppose want all the images which are there inside this particular evidence, right? So go for image. Okay, and here you can also check all the details of particular, mean here suppose see. So we can get the image, and from here you can get the metadata. Okay, here from here you can get the text if anything is there inside that image, then hex value. So you can get all the details by choosing that particular image. So you can also details for every file, and executable file is also there, right? So by MIME type, the file is also there, like application, image, text, like this. So if you want to get all the evidence file by their file format or file type, then go for the view option. Then result, here we can get the extracted content from the image file which we got, like the account. We get two accounts which has been opened. One is Twitter and another one is LinkedIn. Okay. Then exhibit metadata. Okay, we can get lots of uh, right. Now encryption detected. So these two files are basically encrypted. You can also decrypt by using the decryption methodologies. Suspected encryption, then user content suspected, web bookmark, all the bookmark in the web, that is also there. Uh, that cookies information, web download which have been downloaded by the user, that information is also there. Autofill and web history, that is also there. Okay, and email messages, see that part is also there. Not any email is still not there. I don't know, actually the email messages are not there, or maybe it will not till now it complete the analysis, right? Because it will take some time to analyze this, right? Then if any interesting item is there, that is also be shown here, an account. I hope the analysis is not completed, and lastly the report. So depending upon all that analysis, it will provide us the report, right? So now suppose I want to add another data source with this particular case, right? Because we have two evidence. Another one is the memory card, the laptop images, and now suppose I want to add the images which is taken from the, go to the option add data source to add any other evidence. Finish. So you add two data source. See, this is the memory card. Okay, so you also get this in data source. We also get this in views, and in views we can also get all the deleted file as well. Okay, so from here we can also get the deleted file. So further, if there is any encrypted, we need to decrypt this. If there is any deleted file, we need to recover this, and if there is any password protected file, we need to break that file. So that is called defeating anti-forensic technique. That is also another aspect of computer or digital forensic. Okay, so but this is not possible also in this small session. Okay, so now see, in the result part we also got that information, like there are two accounts and metadata 4 file are there. Let's check the exit metadata. So this is the image. Okay, yeah, we got the image of the dog which has been kidnapped. This is basically, let's check. Okay, now suppose I want to check the metadata of that particular image. So let's go to the metadata part. Okay, see, in metadata we can get the file system, MIME type, size, okay, modified date, access date, created date, okay, has hookup. So all that details information. Even if it is taken from a GPS enabled device, and the GPS is enabled when the image is taken, then we can also get the location, that is latitude, longitude. See here for this, you can get the latitude and longitude as well. Okay, let's try to track the geolocation. Location map and show the location from where this image has been taken. Yeah, see, it's showing the, so let's zoom. Okay, let's check the latitude and longitude of this 9.177 and minus 76 point, and altitude is, okay, let's check one, this one. Yeah, this one, this is the location. Let's zoom. Okay, so this is the actual location, and let's once again check the image. It's showing some airport, so we need to check the nearest airport of this location. Okay. The 23rd, 9 hour 28 minute 58 seconds. Okay, 23rd of 17 hours. Let's go to this location. Right, now check this location. I hope this is the location. Yeah, the location. So from it came to this particular location, right, on the same day, that is 24th of October 2019, and also it stay some high-rise building. So altitude showing 15 or 10, and here it's showing altitude is about 9. I hope this is the nearest some type of things where it also found. So this way, by analyzing all these things, we can get all the details from the volatile memory. And here we cannot get all the result if we get the email or other information. Analyzing or checking all the email communication, maybe email ID or maybe the history, then we can get some details as well as regarding this particular case. So this way we need to approach to solve particular computer, right, for a